Hello, this is Rick Guptill with AC&E, and this video is on our vision application where we show how to use a camera, like a camera or a 3D laser or some kind of scanning system, to scan a surface. And we could either use it to inspect the surface, or find it for quality, or if there's something on the surface. Any application really where a robot is going to move a camera on a surface. So what we really want to do is we want to figure out how much coverage we have and how much overlap we want between each scan, because many applications require a 20% overlap, as an example, for the function to work, to really be able to get the scan quality that they need. So the first thing we're going to do is we selected this surface here, and we're going to it turns transparent, and then we're going to move the this scanning parameter. We'll get into it later, but this how to define this camera. But basically, we're going to say just move it perpendicular to the part for right now, so that's aligned with the face of this part that we're going to scan. And then what we can do is, once we get it set up, we can move it, we can drag it along the surface. And this is what I mean by manual teaching. We don't really know, we don't have an automatic way in this example to create overlap paths. In the next video, we'll show how some semi-automatic teaching where it can do a lot of this computation for you. So when we press the pre-visualize the patch, it makes that gray surface, right? And then if it's good, then we say add the acquisition, and then on the right over here on the scenario column, it's adding these acquisitions to the path. So here what we'll do is we'll see that even after you add an acquisition, okay, so we're going to add one more, and that makes 5. That fourth one was off a little bit, so we'll take it out. So really we have this path editing tool right here, this panel, and it allows you to go through all the scans. So that's basically it right there. Is we've kind of set up our scan with 4 different data acquisition stages. So we'll look at the patch analyzer here. Really, this is just a quick way to look at what we've scanned. And in this case, you can kind of see here, this coverage graph, and you can see, just showing it in the patches analyzer above, that the first scan covers 6.69% of the surface. That's of the total surface, okay. And of course it has overlap 0 because there's no previous acquisition. And then that's the cumulative area that we've scanned, 6.69. And then if you look at the coverage graph, that first green dot, that's at 6.69, and it's green because the overlap, there is no overlap on that first one. So it's there's 3 different colors of those: green, red, and yellow. Green means it's okay, red means that the overlap's not enough, yellow means it's almost enough. Okay, so we'll take a look at this again. So the second point, the patch size is about the same, the acquisition size. So the overlaps then at 10% this time, because we have a patch that we acquired last time, and so the cumulative total patch is 12.74% of the total. So this graph is kind of it's heading towards 100%, but it's not at 100% yet, because this is just an example. So you can see here this is heading towards a 20% overlap here. So if that were 20, then that final point would be green, but it's yellow-orange, so that it's almost correct there. So what we're going to do now then is we can show the actual program that's written, and this is kind of in a pseudocode. It just kind of writes it out. It controls it on the screen. We'll change the update rate, we'll run it, and we'll see that's the actual path on simulated in simulation. But if we save it, we can then write it out in sort of simulated code that then we could send to a scanning system, and the scanning system could then use this to program the real robot to do the scan. Alright, so next video we'll talk about semi-automatic programming. Thanks.